Alright, this lecture is going to cover IPv6 and Internet connections. We covered IPv4 in class. If you have any questions, ask me. So to start with IPv6, I'm going to show you a chart that shows you how to convert from hex to decimal and binary. It compares the values. So a hexadecimal 0 is the same as a decimal 0. In binary, it's 0, 0, 0, 0, 4 zeros. And then you can see 1, 1, 0, 0, 0, 1, so on and so forth, up to F, which is equal to a decimal 15, which is equal to a binary 1, 1, 1, 1. So hexadecimal will always be 0 through 9, A through F. And then combinations therein can be converted to decimal and to binary. This chart is just examples showing you binary octets. So you see a hexadecimal 0, 0, 0, 0, and then that equals 8 binary zeros, all the way up to FF, which is 255 in decimal, a number you should recognize, and a series of 8 ones, which you should also recognize. So these charts are pretty helpful. These screenshots are all taken out of our Cisco books, our online curriculum, so you can find this again if you need it. It's in our chapters. This shows you the construction of an IPv6 address. It is 128 bits long, and you can see you have the 8 hextets right here. So 16 binary digits long in each one, and they've broken this out, so if you were to take one of them, you could see that it's equal to 16 binary bits. But it will be displayed as 4 hexadecimal digits. Okay, so there are some ways to shorten an IPv6 address, because I'm sure you're thinking, my goodness, this is massive. You have to write all this out, all these digits. Generally you don't. We actually shorten them quite a bit. We have a huge amount of possibilities for the number of addresses that we have available to us with IPv6. So we generally do shorten them, and they're actually fairly manageable. It's not as daunting as it looks initially. So this is the long way of writing out an address. So you have this address 2001 0D8 DB8 colon 000 colon 000 colon ABCD colon so on and so forth. Now, one of the things we can do is we can take out any leading zeros. So we can omit those. We cannot take out the trailing zeros. So notice the hextets that have all zeros in them, they have left a 0. So then you can compress it down to this. We can further compress by combining one group of hextets that have zeros in them and do a colon colon. You can only do one group. So we could not take this and combine it down to 2001 DB8 colon colon ABCD colon colon 100. We can't do that. We can only do one of them, so we could choose. We could leave this as 0 colon 0 colon and do colon colon 100 here, or as they have done it, we put it on the first one. So the colon colon ABCD, and then we have colon 0 colon 0 colon 100. I don't know why. That's just the rule. And here they've done it the opposite way, and only one double colon may be used. All right. But you can combine it down and see it's become much more manageable and not as daunting. All right, so generally our IPv6 addresses are going to be constructed with our prefix and our interface ID. So your prefix is essentially your network ID. Same thing as in an IPv4, where we have a certain set of bits that are designated to identify what network we're on, and then we have another set of bits that identify our host address. IPv6 addresses are generally broken up in half. So 64 bits identifies the network and 64 bits identifies the interface or the host, which is something else that makes them very manageable, because with a 64-bit network ID and 64 bits worth of host, we have an untold number of IP addresses available to us. We will not run out. We're safe. So here's an example with the numbers in here. You would do 2001 0DB8 colon 000A colon 000, and then interface ID, you have to have some number here. A better example would have been putting, say, a 1 in here, and that would show you an actual host address. This is just a network address. And then this could be abbreviated by pulling out leading zeros, and then it would be colon colon, because this is all zeros, and then say a 1 to identify an interface, which would make it very much manageable. Okay, so we have different types of IPv6 address. We have our global unicast address. This is something that is routable on the internet, and it begins with 2000. So you can see this one up here in their example. This is a global unicast address. Now, it's actually further broken down. I know I said 64 and 64, and it is still 64 and 64, but they actually break up the first 64 because we have two separate networks we need to identify. The first 48 bits are assigned by your ISP. So if your ISP switches over 64-bit, they're going to assign you the first 48 bits. And then you will get 16 bits, which is 1 hextet, so it's going to be 4 hexadecimal digits to identify your network. And then the last 64 bits are going to be your host identifier. Okay, then we have our link locals. These are not routable. They are auto-assigned by the machine, but you can automatically configure them. Now, this is where I'm going to blow your mind. You can have multiple IPv6 addresses for a particular interface. Awesome. So you are always going to get an auto-assigned link local address from your computer if IPv6 is enabled. And it's very similar to the IPIPA address. And what it does is allows you to communicate on a subnet. It's not routable on the internet, so it can't go out. The range of these is FE80 /10. So it's this 10 bits identifies that link local. And an example of a link local address would be FE80::1. Now, this does not look like a big, scary, daunting address, and this is very common for something you would see. The auto-assign addresses that you're going to see are going to be quite large because the machine uses the MAC address of the network card to create the link local address, and I'll show you an example of that. Alright, is there anything else I wanted to say about link locals? Not off the top of my head. I'll show you a couple more things when I show you the ipconfig. Okay, so let's go into different internet connections that we can utilize. So the first one I have on here is a dial-up connection. And you can see you have your computer, the world's oldest computer. We have floppy drives in it. You have a modem. The modem can actually be internal or external. It can be a expansion card that's PCI in your computer, and you can install that, or you can have an external modem. And both are fairly popular. Towards the end of the dial-up days, the internal modems probably became more popular. External modems are generally something you would probably see in server rooms. We always had external modems. And so the way this works is this actually is a modulator demodulator. It uses your phone line, and you would plug your computer into the modem and the modem into the phone line, and then you would dial up. So you would configure the dial-up properties on Windows, and I believe this is from somewhere in the realm of Windows 98. And you set a username and a password because you have to authenticate onto the network. And you have a phone number that you dial. You set up your dialing properties at a different time. It tells you what area code you're in and country code and all that. So you set all that up, and then you click connect, and it will dial out to the phone company that you are using. And they have modems banks on their end, and so the modems talk to each other, and that allows you to connect to the internet. A couple of terms you need to be familiar with: POTS, plain old telephone system. Now this is the line that comes into your home for making phone calls. And then PTSN, this is the public switch telephone network. And this is the network at the phone company that controls your connection. So I said they have that bank of modems that they use, and all the other phone equipment. That's the public switched telephone network. And that has changed quite a bit. I said they have upgraded to digital networks. Dial-up connections offer you speeds up to 56K for a single line. You can do things like team them and get crazy with your dial-up, but most home users just had a single 56K line. And you have to remember that you cannot, when you're using your phone line for internet through dial-up, you choose. If you are on your dial-up connection, you are on the internet and you cannot make phone calls. Alright, so another type of dial-up connection that's a little more advanced is ISDN. And ISDN allows for phone, data, and fax all on one line. This is something typically used in businesses. It wasn't really common at home, and part of the reason for that is that it was fairly expensive to use ISDN. So you have a couple of different flavors of it. You have BRI, Basic Rate ISDN, and this is going to offer you 128 kbits of throughput. And then there's Primary Rate ISDN, which is 1.5 megabits per second, and this runs on a T1 circuit, and this was really quite expensive. And you can see a standard configuration for ISDN. So, you know, you're in your company, you have your Ethernet hub, so you can connect multiple different computers or switch, doesn't have to be a hub. And then that would connect into the ISDN router, and then you would have an ISDN line out to the telecom. And a lot of times, and this is generally used when DSL or cable is not available. Then we have DSL. And DSL is something we were all very familiar with for a long time. Came about really before cable. This was an upgrade to dial-up. And the benefit of this is that you can use your phone and your data at the same time. And so this is typically how you would configure this. You would have your DSL router, modem. We call it a modem. It's not really doing modem jobs for the most part. Everything's digital with DSL, digital subscriber line. And you have it plugged into the power source. You have an Cat5, Cat6 cable running from your computer to the modem. And then you have your phone line plugged into the wall. Now, there's a little trick to that. In order to use the phone, you had to apply these filters. And what the filters do is they filter out the noise from the DSL. So you have the filter plugged into the wall, you have the modem plugged into one side of the filter, and you have the phone plugged into the other side of the filter. And then you can use your internet and your phone at the same time, and you don't get any interference. Home users typically use ADSL, asynchronous DSL. You get faster download speeds than upload speeds. So common speeds for DSL, 3 megabits per second down and 768 up. And this really depends on the quality of your lines. I know where I was living out in Maltby, our lines were really old, so the most I could get at all was 1.5 megabits down and 384 up. So it was pretty slow. And I mean, they would sell me Verizon was happy to sell me 3 megabit internet, but it wasn't even possible for me to get it because my lines were pretty outdated. DSL's gotten pretty fast now, so you can get, I've seen them advertising speeds comparable to cable. They're advertising speeds, I think, up to 12 megabits. So they're getting there. Businesses typically use SDSL, which is synchronous DSL, and this allows for equal upload and download speeds, because businesses oftentimes are going to need those upload speeds, whereas home users, most of what you're doing is download. So you're not too concerned about the fact that your upload speeds are fairly slow. All right, so the next one is cable. And cable is one of our faster internet options, very common for people to use, and this is a typical cable setup. So you have your cable modem, and you have your RJ6 cable with F-type connectors, those little screw-on ones, that go out to your cable connection at the wall. You can put a splitter on there if you wanted to connect your TV to the same line as the one you're using for your internet. And then from the cable modem, you have your Cat5, Cat5e, Cat6 cable running from here to either your computer or a switch or router. You can put a wireless router, whatever, and then that from the switch to the computer. And that's what I would recommend. Many of these modems are now coming built in. This is the same with DSL. Are now coming built in with routers, so they'll actually have multiple ports on the back, so you can connect multiple computers. And many of them are also coming with built-in wireless as well. So you just buy the one device or rent the one device, and you only need the one. And then, of course, you have to connect it to power. This will offer you speeds of up to 50 megabits per second download. And cable does the same thing, where you generally have slower upload speeds than download speeds. And do remember with all of your internet broadband services to check out your soft caps, because many of them do cap the amount of data you're allowed to download per month. Comcast, I think, is around 250 gigabytes. WiMAX, and satellite, they usually cap you around 25 gigabytes. But every provider is different. You need to check. And they're soft caps because usually they won't completely shut you down if you exceed it, but they will throttle you, which means your internet will become very, very slow. Some of them will shut you down and your internet will become non-existent. So it really depends on what you have. Look at your service agreement. And some of them get pretty feisty if you constantly hit your ceiling. So I've read lots of stories on the internet where people have hit their ceilings and their ISP has warned them, hey, you keep hitting the ceiling, you're going to get shut down. And they actually will shut it down and not offer you any internet service. Internet service is considered a privilege, not a right at this point. All right, so fiber optic. This is becoming very popular. Fios, fiber optic to the home, and it doesn't look a lot very different from DSL. It looks very similar. I'm sorry I couldn't find a higher quality image, but this is the best one I could find. So you have your box, so the fiber comes into your home, and you have a box here, and it actually connects what looks like a standard phone line, and that's what connects into your modem. And then it's the same configuration, so the modem connects into a switch, which connects into your computer. Fiber optic offers speeds up to 150 megabits per second, and when Verizon first rolled Fios out in our area, people were getting 100 megabits pretty easily. They now throttle that now that Frontier is in charge of it, and I think most people are getting around 20 megabits. They don't have to, but they do. Alright, so WiMAX is our next technology, and you can see WiMAX is awful similar to cellular. So you have a tower that has the WiMAX adapter 802.16, IEEE 802.16, and then you will have some sort of modem that will take the signal, And generally you need to put this within line of sight, so you have it in a window. There are other ways of doing this. Some people will have external adapters that are outside their home, and then a line runs inside the home, and then you have a modem that looks very similar to your cable modem or your DSL modem, and not with the antennas. This one doesn't assume an external adapter receiving the signal outside your house. So you would put this where you would have the best line of sight, and then your router or internal wireless device would connect to this. Internal wireless access point would connect to this, and then provide wireless for your house or wired internet access. And you can see it goes ranges up to 50 kilometers. Of course, in Washington we always have barriers such as hills, trees, buildings, lovely things like that will lower that range. This does require a line of sight, so that can be problematic. But in fairly open areas, it works really well. And it offers speeds very comparable to DSL and cable. It's a pretty good option if you are in a place where you can get good reception. Then we have satellite. So here's how the satellite works. You have your internet provider, and they have a dish, and you have the satellite floating up in the air about 22,000 miles up. And then you have a satellite antenna at your house that receives information from the satellite up in the air. And then you have a satellite modem, which is very similar to the cable and DSL modems, that connects to your computer, or you may have a switch in between here, a router, wireless access point. Satellite speeds, once again, very comparable to cable and DSL. I googled it really quick, and people were saying, around 12 megabits a second, which is pretty good. The problem with satellite is it has really high latency, so it's not very good for things like video gaming, where latency is very important. You're playing WoW and you're in a dungeon, and if your latency goes too high, you're going to cast your spell and not see it happen for X amount of time, or you're casting too late, you're reacting too late. So it's just not great for video games. But if you're just, need internet connection, you live out in the sticks, you need internet connection for a business purpose, it's a very good option. The next one is cellular, and you can see here's a picture of a cell tower. I'm sure we've all seen these all over the place. And we have our handheld devices generally contain cellular antennas, and so you'll have your cellular antenna. You can also get cellular cards for laptops in the form of a express card. You can also get these little jetpacks. So this is a picture of a Verizon jetpack, also known as a MiFi, and basically it's just a little cellular card in a box, and you turn it on, and it basically provides a wireless access point. So then computers can connect to that wireless access point, and it acts as your cellular modem card. And I said the word modem because I'm old school. Sorry about that. All right, so speeds, 3G. There's others. I mean, it's the technology's been around for quite a long time. I remember using my BlackBerry on Edge. It was very exciting. Generally, our phones now are 3G and 4G. So 3G can give you from 2 megabits a second up to 14 megabits per second. If you're moving around, your data throughput can fall down to 1 megabit per second. So moving slows you down. Stationary, you should get a little bit better rates. 4G is quite an improvement. 100 megabits per second when moving, up to 1 gigabits per second when stationary. Now, I know a lot of you are going to say, that's ridiculous, I don't get those kinds of rates. Well, network congestion is a major factor. I remember being at a BlackBerry conference, and there were 6,000 people in a hotel at Disney World, so that's in addition to all of the people who were also at Disney World, and it was impossible to get any kind of internet connection, just impossible through the cellular, because there were so many people. That is the extreme end of network congestion. But, you go to places like CenturyLink Field, you're at an event, you'll notice that your data rates are much, much slower. Okay, and then lastly, I wanted to go over configuring network cards, because this is something we're going to do in class, and so I want to demonstrate it right here. It's somewhere repeatable. You can watch it over and over again. So when we're setting up our networks in class, we're not going to be using DHCP. DHCP is a dynamic method of distributing a IP address to a computer. You have some sort of DHCP server. Your home routers will perform DHCP functions for you and hand out an IP address. What we're going to do is we're going to set up some ad hoc networks, and so we're going to be manually configuring this, and you should know how to do this. So in order to get to your IP configuration, you can also do this via command line. I'm going to do another video demonstration that's going to demonstrate a bunch of command line tools that we can use, and one of them will be NetSH, so where you can configure this via command line. So I put all the icons on the desktop. This is Windows 7. Typically the icons are not here. In order to put the icons on the desktop, you right click on the desktop, go to personalize, and then click change desktop icons. And this is where you can check the boxes to have the icons you want on the desktop. Some people like a very clean desktop, and I do not fault you for that. I like having the icons on the desktop. I am an icon junkie. Some people call it a fault. So I put all the icons on the desktop. Now, you can also access this through the control panel. So if you go into the control panel, and I like to view by large icons, once again, my icon issues come out, and we can go into the network and sharing center. And this is going to allow us to configure our adapter settings. Then once again, it's always more than one way to skin a cat in Windows. We can ask for anything through the search bar. So if I type in net, it'll give me my network icon, which I can then right click on and go to properties, and that's going to open up my network sharing center. Or I can see right here, network and sharing center is one of my options. So we're going to go into the network and sharing center, and we're going to choose to change adapter settings. Now, we will see our adapters here. If I had a wireless card in this computer, and this is a virtual machine, so it's even a little more different. If I had a wireless card in here, you would see my wireless adapter card. If I had Bluetooth in here, you'd see that. Any of my network adapters would show up in here. So I've got my one network adapter that I've configured on my virtual machine. I'm going to go to the properties of that network adapter. So it's a right click and then select properties. And in here you can see that I have some configuration options. If I click here on the network adapter itself, this is where I can manage driver information if I need to. So I can go up here to drivers and driver details, update driver, if I need to do any of that. And this is also where I can configure some of the power management settings. This is actually a really interesting configuration in the realm of PC tech, because one of the options in here is allow the computer to turn off this device to save power. And this is part of your ACPI settings that allows the computer to go to sleep and hibernate. I actually like to leave this unchecked. I've seen this cause problems before where computers lose their network connections because the device goes to sleep and for some reason it can't restore. Mostly I've seen it with laptops and docking stations. So that can be problematic. Now, one of the other options is allow this device to wake the computer. And there's a technology called Wake on LAN. And for me, it's grayed out right now because I do not have it enabled on my computer, my host computer. And so it's not passing through to the virtual. But so if you don't have it enabled, it's something that you enable in the BIOS. And if you have that enabled, this will be available to check. And what it means is that you can send a signal over the network to your computer, and it will signal your computer to turn on. Problem with Wake on LAN is that any kind of surge in the lines, the computer can mistake the surge for a magic packet. They call them magic packets, and turn your computer on. Could be good, could be bad. I don't know that it really matters, but my sister at one point was convinced there was a ghost in her office because her computer would randomly turn on. She would come in the morning and sometimes it would be on, and I said, oh, that's not a ghost, it's Wake on LAN. I'm sorry, you think you work in a haunted building, but it's just Wake on LAN. Nothing all that exciting. You have old wiring and it's probably just surging. Okay, so if we go in here and we go to the properties, and we can then configure both IPv4 and IPv6. So let's start with IPv4. So we click on IPv4 and we go to properties, and we're going to see the ability to configure our IP address. So if I would like to use a static IP address, I would come in here and I would tell it I want to use numlock. I want to use 10.20.30, and I'm going to assign this a host address of 23. And the subnet mask that I'm going to use, if you click on this, Windows defaults to the classful range. So we remember we talked about 1 through 126 is class A, and default subnet mask for class A is 255.0.0.0. Now, I'm actually going to subnet this down, so I'm going to use a /24, which is going to give me a subnet mask of 255, 255, 255. So that means that I will have 255 addresses available for my hosts. And I can tell you we will not be able to plug 255 computers into the one switch I'm going to give you, so that is more than enough addresses. And the other thing that I want you to recognize is that I'm using the 10 network. This is one of our private IP address ranges. Now, default gateway. Our default gateway allows us to get out to the internet. So let's assume that we had our switch connected to a router. Now the interface that is going to be facing us is going to be our exit interface. This is how we get out of our network and onto another network. This is also known as our default gateway. So if we had a default gateway, we would configure that, and so the interface of the router, typically people will either use the first IP address in the range or the last IP address in the range. And so it will be on the same network, so it's going to be 10, 20, 30, and we're going to use the first one, so we're going to give it 1. And then lastly, we have use the following DNS server addresses. Now, I do not have to configure this. I can leave this blank, or I can set it up. And DNS, domain name system, and this translates IP addresses into, or host names into IP addresses. You can do reverse lookups, which is IP addresses into host names. And without DNS, we would have to know the IP address of everywhere we wanted to go. If we wanted to connect to our neighbor's computer, we have to know what their IP address is. If we want to be able to use the host name, we have to use DNS. So there has to be some sort of DNS server that's giving us that information. Alternatively, if we don't want to use DNS, so say in an ad hoc network, we could actually use the hosts file in Windows. And this can be found in the Windows System 32 folder. And the host file is just a list of IP addresses and host names. And our computer will look at that. Our computer looks in a couple different places before it actually asks DNS for the information. It first looks in our DNS resolver cache, which is just a little memory space that remembers places we've gone before. And if it can't find the information there, it will then look in the host file and say, hey, do you know the IP location for this computer name? And if it's in the host file, then it will use that. If it's not in the host file, it then goes out to DNS and says, DNS, do you have an entry? Do you have an A record for this particular computer? And if DNS has it, it passes it back and we can get there. If it does not have it, we will not be able to get to our destination unreachable. So in that case, we would have to use an IP address to get there. So if you guys are going to have 10 computers in your ad hoc network, you will have to connect to them via IP address. So if you want to get from computer 2 to computer 4, you're going to have to type in 10.20.30.4 to be able to access that computer. I don't have a DNS server. If I did, I could put that information in here. And then you can have a primary and you can have an alternate. And the reason for that is if your primary goes down, you have another mechanism, because it is very important. This is more important when trying to get on the internet. Who wants to memorize the IP address of every site they like to visit? Amazon, Google, so on and so forth. So nobody wants to do that. And then you can choose to validate settings upon exit if you want, and it will tell you whether or not your settings will work. And then we have our advanced TCP/IP settings in here. This shows what IP address we have configured and our gateways configured, and we can add more, we can move them. This is our DNS servers. If I had configured those, you would see those in here. This is our DNS suffix. So our DNS suffix tells us essentially what network we're on and what networks to check, but it uses the suffix name. So in our classroom, it's classroom.lan. If we had multiple domains that we wanted to utilize, so we want it to resolve, if we go looking for PC1, if classroom.lan is the only DNS suffix that we have configured, it's going to look for PC1.classroom.lan. If we add multiple suffixes in here, it will look for PC1.classroom.lan, PC1.school.lan, PC1.a+.lan, whatever. Oh, a+ is probably not. A+ spelled out. .lan. And we can add those in here, and it will look at them in order. And this is when you have multiple domains configured, you use this. WINS is what Microsoft used before DNS. They use their own name resolution system, and so this is a deprecated technology. It's very rarely used. Occasionally you'll have some legacy software that may require it. This is where you would configure that if you run into WINS. Okay, so I'm not going to configure that because I'm going to continue to use DHCP, and that's when it says obtain an IP address automatically, it's DHCP. So then let's take a look at IPv6. We're actually not going to be configuring this and using it, but I want you to be familiar with it. So if I wanted to configure IPv6 manually, I would then type in my IPv6 address, and I'm going to give it FE80::5, and then you generally give it a suffix length, which it's going to default suffix length, which it will default to 64, because most addresses are r/64. You can go, you can subnet this down or up, but the 6/64 is typical. And then same thing, you have a default gateway. Typically with our routers, we actually will use the link local address for the router interface, not a global. So your router is usually 1, so we'll do FE81, and then same thing, we would have our DNS servers, and you can validate on exit, and then our advanced settings look very similar. So you have IP settings, you have DNS. WINS does not support IPv6. Remember, it's a deprecated technology, so you won't see that tab here. But same thing, we can add extra DNS suffixes if we would like to. And then this shows us our configuration information, and we can modify that if we need to. Alright, so we're not going to configure that. Actually, I probably should have left it in here. Now, the other tool that I want you guys to be very well aware of, the one command line tool I am going to show you, to get into your command prompt, go to your search bar and type in CMD. And then you can just hit enter. You can see this is the only one here it's highlighted, or select it. And I want you to notice that it says Windows System 32 CMD. Now, if you want to do anything more than just a few query commands, you actually will need to run this as administrator, because by default it doesn't run as administrator. The UAC, user account control, is going to say, hey, are you sure you would like to elevate your privileges to do this task? And you're going to say yes. And UAC is there to prevent rogue applications from automatically gaining elevated privileges. And if you'll notice now at the top of the bar, it says administrator, and then the path to the application. So we are now running this under elevated privileges. And there are certain things that we cannot do, such as releasing an IP address or renewing an IP address, unless we are an administrator. So I'm going to type in ipconfig/all, and this is going to display all my configured network card settings. So you're going to see my local area adapter, It does give you some other information like my computer name. I never changed it, so this is the default computer name that Windows assigns when you install the computer or install Windows. And you'll see my network card. You'll see my physical address. This is my MAC address. So this is that 48-bit MAC address that I was telling you about in class. DHCP enabled, yes, it is using DHCP. Auto configuration enabled, yes. So, link local IPv6 address. All right, so this is my IPv6 address that is auto assigned to me. You'll see this %11 here, and you'll say, what in the world is that? This is actually it's a zone identifier, if I remember correctly. And this is actually dependent upon the operating system as to what number this gets. The %11 is a Windows identifier, and the reason for these identifiers is because you can have multiple IPv6 addresses on one interface. So you have to identify which IPv6 address you're talking about. And so that's what the percentage sign is about. Here's my IPv4, 1050.130.100. You'll notice this looks very similar to our classroom because I have my network here set up to mimic what we have in our classroom. My subnet mask, I'm using a /24, so it's 255.255.250. And then it's going to give me some information about DHCP. It's going to say my DHCP lease was obtained on Sunday, May 4th, and it expires Sunday, May 11th. The default DHCP length is 8 days. So when it expires, it will renew another IP address. It'll probably renew the same one. It generally gives you the same one back. And then my default gateway, 1050.131. So this is my router interface that gets me out of my network. The DHCP server is located at 1050.131. What does that tell you? Well, that tells you that my little Netgear, it's either a Netgear or Linksys router over here in the corner, is running my DHCP. And here's a little bit more DHCP information. This has to do with DHCP v6. So this is pertinent to DHCP assigning IPv6 addresses. There's a couple different ways you can assign IPv6 addresses. You can manually configure them. You can use the auto assign link local, or you can use something called SLAAC, SLAAC, and this is where your router assigns the IPv6 address. And this is probably the most popular method of assigning IPv6 addresses. But you can use DHCP with IPv6. It's not necessary. All right, my DNS server, 1050.131. Well, what's that tell you? It tells you that my routing device is also running my DNS. So these are your configuration informations, and this is where you're going to go check to see what you have. So let's say I disconnect the computer from the network, not disconnect it from the network. I turn off DHCP on my router. So if I go into my router and I disable DHCP, what IP address am I going to see in here? I log into my computer, I open up the internet connection, and I can't get out to the internet. It says page cannot be displayed instead of Microsoft Internet Explorer taking a million years to actually connect to the internet, which it will do eventually. So it's connected to the internet. If it didn't connect to the internet, and I said, wow, that's weird. I look down here and I have internet access, or network access. Why is it not going in? So if I open this up and I run an ipconfig, this IP address is going to start with 169.154. We talked about that in class. That's a PIPA. That's the auto-assign address that Microsoft uses when it says, well, you're on the network, and if you want to communicate with other devices on the network, you can use this address, but you can't leave the network. You're going to be stuck here. You cannot get to the internet. You have no internet access for some reason. You can't get an IP address to and other configured information. DHCP assigns you your DNS servers and it assigns your default gateway. And so without that, I can't get out. So I can either manually configure something or go fix DHCP. So that's when you'll see that. Even though people get annoyed with a PIPA, it's a wonderful tool because it tells you that you're connected, but it's not working. And that's actually what you'll get when you set up your ad hoc LAN, your ad hoc networks. You'll see some of the PIPA addresses. All right, so that's basic network configuration, and we will be doing that on Monday. And like I said, I will do another video talking about some command line tools that we'll need to be able to know and use.